So let's talk a little bit more about public and private class members. So the public and private keywords in C++ control which code has access to member class. Public members and methods are accessible to all code. So for example, you could access those members from main, you could access them from other functions, or anywhere that class is being used. If a member is labeled public, you can access that member of the class. However, private members and methods are only accessible by other member functions within the class. For example, inside area can always access anything within the rectangle class, whether it's public or private. And private lets you know if you're using a class in your code, anything labeled private is not something you have direct permission to modify if you're modifying code outside of the class. So here's that code I showed you again. So when we wrote the rectangle class, we had this public keyword at the very beginning, and this tells us that width, length, and area are public members of rectangle. And that means wherever we have a rectangle object, any code is allowed to access the width, the length, or the area. So any code could change the width, change the length, or call area. Right, and that's exactly what we do in main, right? We create a rectangle object R, and then by accessing the width or the length of this class, I can modify it, and then I can also call the area function to print it out. Now, on the other hand, if I had put private there, then what that says is that the access of private members outside of the class is illegal, and that's a syntax error if you try to do it. And this private designation applies to everything that comes after it. It doesn't just apply to width, the first thing after it. It applies to everything that comes after it until you specify another access modifier. So that means, since I put private here at the beginning and I didn't put after it anywhere else, that means everything following it is going to be private. And so down here in main, when I try to access the width or the length, these are going to be syntax errors that get flagged by the compiler. And even area, if I try to call area, that's also going to be a syntax error. Now, it's perfectly fine for me to declare a rectangle R. I just can't access anything after the dot because the width, the length, and the area are all private. So I can have a rectangle, I just can't really do anything with it. Now, a more useful arrangement that's often followed when we make objects is that we want the data members to be private so that they can't be modified arbitrarily by other code. But we make the member functions public so that any other code can call those member functions and kind of query the status of the object. So here I've put private at the top and made width and length private. And then after it, I have the public keyword, and everything that comes after public now becomes public. And so this area function will be public. And what that means is that I can declare a rectangle and then call the area function on it, and that will be allowed. And this code will run. But there is a weird thing about this code, and that is if width and length are private, there's no way for me to set their values. And if there's no way for me to set their values, then they're uninitialized. And if I call r.area on this rectangle object that I just created here, called r, if I call this area function, then it's just going to apply whatever width happened to be in that memory location where this rectangle gets created. And so it's going to be garbage. And that's not good. So I definitely don't want garbage. So what I could do to help myself out is add another function into my class. And so let's add an init function, short for initialize, that'll take in an integer w and an integer l. And then inside this function, set my width field to w and my length field to l. Now I'm allowed this because init is part of the class. And since init is a method in the class, it's allowed to access fields in the class, even the ones that are private. And so I can ask this init function to do the initialization for me. And so now inside my main, I declare my object rectangle. I declare my, declare this object called R, and then we call the init function on this object and pass it 10 and 5, to initialize the width to 10 and the length to 5. And then in the next line where I call the area, now this area calculation is going to properly calculate the area as 50 and return that value and let me print it out. Okay, so now this is a slightly more usable class. Now, why did I bother making width and length private only to just create this, initializer function that's then going to set them for me? It seems like I'm making things complicated. Well, I am making things a little more complicated in this simple example. Like it's probably make width and length public in such a simple piece of code. But as the objects we make get more complex, there are going to be a lot of situations where we want to prevent ourselves from accidentally modifying a member variable of an object. And by hiding it behind a function like this, putting it inside a function to do that modification, then we can enforce rules about how those member variables get modified. And this is going to give us some additional confidence that our code is modular and encapsulated and working properly. That the only way to make changes to these member variables are within functions in the object, as opposed to functions that could be anywhere else in the program. And I have to worry what other programmers or other code might be doing to my object. I know the only way for width and length to get modified are in my init function. And so if there's no bug in the init function, there's hopefully no bug in my object.